Okay, question 1. Simplifying expression, no big deal. And we talked about the variables the other day. But as we work through this one, what I notice is on the x to the 6th, and then number 2 is the x to the 9th, and the x to the 20th, man, those are getting to be very large. So I went and talked about kind of the shortcut what's going on if you have not noticed that yet with variables. 12, let's do our prime factorization there. That's nothing to worry about. 2, 2, and 3. But again, x to the 6th, okay, that's not too bad. I can expand that out, but it is kind of annoying, okay? So pairs make perfect squares. So out front, I got a 3 already. I'm going to bring out a 2, and then I'm going to bring out an x, another x, and an x. For each pair, 1 comes out. 3 was by itself, so that stays underneath, and I get 6x to the 3rd cubed root of 3. So if you haven't noticed yet, the shortcut is, because we're doing pairs, groups of 2, we're going to see how many groups of 2 are there in x to the 6th. Since there was 3, that's how many is going to be brought out. Now, we'll do the same thing, but on number 2, I'm going to expand out 27, which is 3 times 3 times 3. Now, x to the 9th, I'll go ahead and expand it out one more time, just to talk you through that. Make sure I get, let's see, 4. I think I need one more. And pairs make perfect squares. But when it's an odd amount, okay, you're always going to have 1 left over. So you're going to divide by 2, x to the 9th. There's 4, but you're always going to have 1 left over. So instead of expanding that all out all the time, that's what I'm doing. So I get a 4. I bring out a 3, and then I'm bringing out for each pair of x's 1. X 4 times. And then I have a 3 left over, and then I have a single x. Anytime, again, it's odd, I'm going to have 1 x left over. Okay? Number 3, we'll go the same way. Now, number 3, the 16, that is perfect. So the square root of 16 is 4. And x to the 20th happens to give me 10 pairs of 2s. So I'm going to have 10 x's out front, or we can just say x to the 10th. If you expanded out 20 x's, you're going to find 10 pairs of 2s. And final answer is 12x to the 10th. So this was actually a perfect square. And then number 4, 5, square root of 48 there. Do your prime factorization. Now, I'm not going to span that out anymore. I'm going to use kind of my shortcut. Pairs make perfect squares. I got a 5. I got a 2. I got another 2. 3 is going to stay underneath. Now, x to the 7th divided by 2. That is 3 with a remainder of 1. So x to the 3rd. Y squared. I got 1 pair in there, so 1 comes out, and there's going to be nothing left underneath. So what is that? 20x to the 3rd y, square root of 3x.